In this example, we've got a compound that is found to contain 49.98 grams of carbon. I left the G off in that. Let's go ahead and write that in there. Grams of carbon, 10.47 grams of hydrogen, and then it's got a molar mass of 58.14 grams per mole. And we want to find the molecular formula. Notice how in this sample problem, or this practice problem, it does not tell me to find the empirical and molecular formula like the previous one did. See how it says find the empirical and molecular? Well, even if it doesn't tell you to find the empirical formula, you have to find the empirical formula in order to find the molecular formula, if given percent composition, okay, or the mass of each element. Okay, so I'm still going to find the empirical formula first. Okay, I know that I've got 49.98 grams of carbon and 10.47 grams of hydrogen. Okay, let's go ahead and get to moles so we can see that ratio. So I'm going to take this and turn it into moles of carbon by dividing by 12.01 grams of carbon, because there's 12.01 grams in 1 mole for carbon. That's going to give me moles of carbon. Let's do the same for hydrogen using hydrogen's molar mass. I know 1 mole of hydrogen is 1.01 grams of hydrogen. So we're going to end up with moles of hydrogen. Let's do the math. So we're going to take 49.98 and divide it by 12.01. This gives us 4.1615 moles of carbon. Here I'm going to take 10.47 and divide it by 1.01. Okay, this gives us 10.3663 moles of hydrogen. Okay, again, I'm going to divide by the least number of moles to end up with the ratio of moles to each other. So 4.1615 is the least number of moles. Okay, this is going to give me 1 mole of carbon. For this, I'm going to have 10.3663 divided by 4.1615 and get 2.5. Remember, if I end up with a half number, I need to multiply everything by 2. So there's 5 moles of hydrogen for every 2 moles of carbon. So my empirical formula is going to be C2H5. Okay. Now, I know my molecular formula, or the actual compound, whatever it is, has the mass of 58.14 grams per mole. That's its molar mass. I can see how many times my empirical formula that is by finding first the molar mass of my empirical formula. So I'm going to take carbon and hydrogen. I know that carbon is 12.01 grams per mole, and I've got 2 carbons here. So that's 24.02 grams per mole. All right, hydrogen is 1.01 grams per mole, and I've got 5. So that's 5.05 grams per mole. So the molar mass of my empirical formula, so my empirical formula molar mass, okay, is going to be 29.07 grams per mole. Okay. So I'm going to write it this way. X times my empirical formula is going to be my molecular formula, because remember, this is always the lowest whole number ratio. The actual formula, or the molecular formula for your compound, is going to be some whole number multiple. Okay, so X is how many times that would be. So to find X, I'm going to divide both sides by my empirical formula's molar mass. So X is going to be my molecular formula's mass divided by my empirical formula's mass. I'm going to take this 58.14, okay, you can keep up with your units, grams per mole, okay, divided by 29.07 grams per mole. You'll notice that since the units are the same in the numerator and denominator, that the units will cancel, and we're left with just a number, which is good because we're looking for how many times we should multiply this. Okay, when you plug that in your calculator, again, some of you guys might already be able to see what this is going to be, but just to plug it in and practice. So 58.14 divided by 29.07, again, is exactly 2. Which means my molecular formula is twice as large as my empirical formula. So if that's my empirical formula, my molecular formula will be C4H10. See how that's twice as large. There you go.